let's finish up this handout on reference angles. We have two more exercises to do. And number 4 was pretty intense, I think. And so I think we're going to, let's do one that's not quite so intense. We're going to move on to exercise 5. And I think 6 won't be so intense either. Exercise 5, sketch negative 15 degrees in standard position, then find a reference angle for negative 15 degrees. This is easy. But you got to make sure you get the point here. Negative 15 degrees in standard position is going to be, maybe I drew it a little large, exaggerate a little bit, something like so, right? Now the reference angle for negative 15 degrees is formed by the terminal side in the x-axis, so it's right here. But the reference angle is always taken to be a positive number. It's considered not to be in standard position. So the reference angle is positive 15 degrees. So don't ever say that a reference angle is negative. That cannot be true. So there's not really anything to calculate here, but you just got to know we say the reference angle for negative 15 degrees is positive 15 degrees. And exercise 6, another funny radian measure one. This one's not really that bad either as the last one we did. But this is a radian measure that we're not very familiar with, negative 4 pi over 5 radians. And I forgot to say in the last video, maybe I should say here, that if you're really stuck, you could convert to degrees, but then you got to convert from degrees back to radians in your final answer. So we're going to try to work with degrees here so we can avoid those extra steps. And I think here the way to think of negative 4 pi over 5, which is not, again, not one of the special angles or a multiple of a special angle at all, is just to observe that if you can notice that negative 5 pi over 5 is negative pi, which is negative 180 degrees. So negative 5 pi over 5 in standard position would just come around, sweep through the bottom half, right, of the coordinate plane. So we're going to be just short of that because we're negative 4 pi over 5. And that allows me to draw negative 4 pi over 5 in standard position. It doesn't really matter where you draw the labeling, but realize what's important is its terminal side ends up in quadrant 3 here. And because of our observation, it shouldn't be too hard for you to guess to see what the reference angle is, because we're just pi over 5 short of, this being a negative 5 pi over 5 or negative pi. And so pi over 5 is the reference angle. Don't say negative pi over 5. Reference angle is never negative. It's always positive. It's not in standard position. And you can calculate it by taking pi minus 4 pi over 5. So you'd have to think of it as, but you shouldn't even have to. You should be able to just see this in your head, I think. There's that pi over 5. All right, and we're through. So I'm going to stop here. Now, in the next segment, now we're going to start talking about what do we use these reference angles for? We know how to find them. What good are they? And that's coming up.